Let's go. Okay. Wow, that's loud. Good morning and welcome to Build 2013. I hope everyone here saw Steve's keynote just now. There was certainly a lot of really exciting news that came out and a lot for us to all absorb, lot for all of us to absorb there. Now it's my job to get us through to lunch, and to do so, I'm going to talk to you about the Windows desktop. So my name's James Clark. I'm a program manager on the Input and Composition Engine team in Windows. We like to refer to it in a friendly way as ICE, the ICE team. And I'm here to talk to you today about desktop applications, and specifically how you can take advantage of some of the improvements that we've made to the Windows platform to optimize your desktop applications to work with some of the new and exciting form factors that you just saw in the keynote. Now, I'll call out up front, this talk is focused primarily on native APIs that sit at a foundational level in the stack. And so it'd be primarily of interest to C++ Win32 developers. That said, if you're a managed developer, don't worry. I think you'll still find the talk interesting. You'll get some insight into how the system works. And also, I do have a little bit of WPF for you C# lovers out there. If you're a native developer, I hope you'll find the possibilities to be exciting and actionable. Now, before we get started, I want to tell you a little bit about me. I've been with Microsoft now for 7 years. I started off on the Expression team, and I moved to Windows back at the beginning of Windows 8. I joined the UI platform team, and I focused primarily then on web animations. Now, for the last year or so, I've been working on Windows 8.1, and in that regard, I've been working on the desktop window manager component that's a low-level kind of composition component in Windows, and big parts of Win32. And most specifically, I've worked on the high DPI and multi-mon work that you just saw in the keynote. So let's take a quick look at the agenda I'm going to talk about. First thing we're going to do is look at some of the device form factor trends, and this will kind of build on what you saw in the keynote just now. We'll then focus in and look at some of the changes in the Windows 8.1 platform and how those will help you address these form factor changes that are occurring. And then we'll spend the remainder of the talk focusing on 3 primary areas. The first one is supporting dense screens, high DPI screens in desktop applications. We'll then talk about composition and animation. And finally, we'll finish up talking about some input-related topics. So to get started and talk a little bit about form factors, I'm sure many of you will have what you saw in the keynote today will have resonated, because I'm sure you'll have also been tracking Computex that happened back at the beginning of this month. And there were some pretty clear signals already coming out of Computex, and that's that there's really never been such a diversity of form factors that people will be buying and using over the next year. And these are the form factors that people will be using to experience your desktop applications. So one example, displays. They're coming in an ever-increasing set of shapes, sizes, and resolutions. And the form factors themselves are becoming ever more varied, and Steve highlighted this just now. According to Intel, there's actually been more mechanical innovation in devices in the last year than in the last 10 years, and I think this tells us a clear message. In terms of categories, Steve also talked about the Ultrabook 2-in-1 form factor, which is this new kind of hybrid class of device that works as a tablet when you want consumption, and then when you want to get productivity done, it converts and works as a laptop. And at the same time, these devices come in thin and light form factors and also have amazing long battery life, all-day battery life, as well as multimodal input, so touch, pen, and so on and so forth. And the idea is really that you can carry one of these hybrids and carry that instead of a laptop and a separate tablet. Now, this resonates with me personally. I've been using a Surface Pro for the last couple of months, and you guys, I'm sure, are delighted to understand that you'll be getting Surface Pro devices yourselves. These things are really awesome, and I actually bought one, and I use it as my main machine both at work and personally. This is the first time I've ever really done this, so the whole bring your own PC to work thing, something I completely love. So what I'm able to do is, when I'm out and about, I'm doing kind of my own personal work. I log on to the system. I don't use my work domain account. And I can get stuff done. I can take, pictures and import them. My daughter was here doing a recital. It was a very long recital. I wanted to kind of start ingesting photos. Was able to do so on my lap using touch as an interaction form. Then when I'm sitting back at my desk, I log onto my domain account, and I use all of the productivity features, heavy user of Office, Visual Studio. And with an external display, I'm able to really kind of capitalize on the small, lightweight device, but with the power of the desktop at my disposal there. And finally, I'm somewhat of a developer in my spare time. If I can get the clicker to actually click. It's not going to click. OK. It's a shame. And so when I'm kind of out and about in coffee shops, again, I'm logged onto my personal account, and I'm able to get development work done on the same device. And this really is kind of like the thing that I carry with me everywhere. So let's look at some of those form factor trends in a little more detail. On the display front, we've seen a new wave of high DPI displays coming. And on the desktop, this is very much in the form of 4K. I'm sure you'll have heard a lot of the buzz around 4K. Asus have a display that's about to ship called the PQ321. That's a 31.5-inch Ultra HD panel with a resolution of 3840 by 2160. And this is 4 times the resolution of a regular 1080p panel. And these things are shipping now. On the mobile side, Surface Pro started the trend, and you'll see this when you get your device. You'll actually kind of get to experience the 208 DPI 1080p screen. But there's also an accelerating trend, and there's a particular trend where 13.3-inch devices are coming to the fore. I've got a couple up here. One is the Kira Book from Toshiba. The other is the Samsung ATIV. I need to get it right. Samsung ATIV Book 9 Plus that I have. And this thing has really got an amazing screen. It's got 3200 by 1800 pixels. And it really is quite an amazing resolution. I definitely, if you haven't seen one of these in the flesh, definitely go to the expo, or I'm happy to kind of show folks after this talk. Really have a look at that screen. It's amazing. So, I mean, what that means from a developer perspective is that the norm of 96 DPI is the thing that you can reliably kind of trust to be the DPI of choice on systems out there is really no longer the case. DPIs are going up, and this is a concern. It's an opportunity as well, but it's something that we'll think about and talk about a little more depth in this talk. So not only we get it to click. Not only is the density and the DPI of these screens rising, but also the diversity is coming in the size and shape. And we see things like the Acer Iconia, the 8.1-inch screen. But also on the desktop, we're seeing new and interesting aspect ratios like 21:9, so some of these incredible kind of widescreen displays that you see there. Now, on the input side, one of the things that we're excited to talk about today is Precision Touchpad. And this is a new initiative that is going to come out over the next year. Who here has got frustrated with the touchpad on their laptop? I'm sure many people have. Well, we really wanted to fix that, and so I'll talk about this in more detail and actually give you a demonstration, but we actually really want to make touchpad a first-class experience in Windows. And let's not forget touch as well. Touch was a real mainstay of the investments that we made in Windows 8. And touch isn't limited to mobile devices. Again, we heard this morning in the keynote. Touch is very much present across all form factors. And those form factors where it's present is where we're really seeing a lot of great satisfaction with Windows 8. OK, so finally, we've come on and think about fundamentals. We know that CPUs and GPUs are becoming more diverse. But at the same time, graphical richness and the expectation that the OS and applications themselves are very immersive and rich has gone up. So users expect fluid animations and responsive panning and zooming. And this is despite the kind of power-first architectures that are coming out from chip manufacturers now, where they're trying to eke out every last minute of battery life. And this is a real dichotomy for developers, because you essentially are faced with a challenge of either optimizing for fluid UI at the expense of battery life, or you're conserving power to the degree that your animations stutter and don't feel fluid. So let's look at some of the things that we're doing in Windows to help address some of these challenges. And to present those to you, I'm going to use this Boxology slide. This is similar to one that you'll have seen 2 years ago when we launched the Store app platform. I guess it wasn't, was it 2 years ago? Yeah, it was 2 years ago. Wow, time flies. And you see there the Store apps positioned next to the desktop apps. And what I've done is actually added a new layer underneath. And this is highlighting some of the APIs that exist in the system to power not only Store apps, but also desktop apps and the system itself. And this is what we're going to focus on today. So we're going to focus on input, interaction, and manipulation, and then rendering, composition, and display. So if we go in and look in a little more detail, I'm going to start and work left to right here, and we'll start by talking on the input and interaction side. So the fundamental of input and interaction for desktop applications is the WM Pointer family of APIs. And this provides access to raw input messages such as mouse clicks or touch contacts. And one of the advances that we've made here is the unification of the different modalities of input at the API level. So if you program to WM Pointer, you're actually going to be handling mouse, touch, and pen with the same code path in your application. Now, the next layer up is interaction context. And here, if you actually want to start taking the raw pointer input stream and disambiguating between gestures such as press and hold and tap, interaction context makes that very straightforward. And then at the top of the stack on the input side, if you want to kind of consume entire manipulations such as panning and zooming and have the system handle those for you, direct manipulation is available. And we'll talk about these in more detail later on. Now, if you're building specifically an ink-enabled application, we have both real-time stylus API that allows ink to kind of feel like it's flowing from the pen, very low latency, and also gesture recognition capabilities that allow you to take that stream of ink and actually convert it into objects that the system can then work with. So now to move on and talk about the rendering and composition side. I'm sure that many people are familiar with Direct3D. Direct3D has underpinned the graphics stack in Windows for many years now, along with DXGI, and it offers to the Metal graphics performance and the ultimate control on how you get your rendering done. Back in Windows 7, we added Direct2D, and this is an immediate mode rendering API for bitmaps, 2D geometries, and we added capabilities in Windows 8 around imaging, and in Windows 8.1, we're adding new capabilities around color fonts to Direct2D. And then finally, at the top of the stack, we've got a new system composition engine in Windows, and this is powering a lot of what you see and feel in apps, in store apps, in the shell itself. And some of the new capabilities you saw just now in the keynote, like some of the enhancements to WebView, are all powered by this system compositor. And really, direct composition exposes the system compositor developers and enables content like bitmaps and video to be composed together within an application with overlapping regions and have effects such as opacity and clipping applied. Finally, one of the new areas that we're adding in Windows 8.1 is the per monitor DPI, or the dynamic DPI APIs. And this is a set of APIs that allows you to take advantage of the capabilities you saw in the demo, where applications can run on screens with different DPIs. But you can actually use these APIs to customize the rendering and really get excellent quality of output. Now, at this moment, I wanted to tie together the device opportunity as well as the API surface. And so I wanted to invite up on stage Jerry Harris from Adobe. Jerry's a principal scientist on the Photoshop team, and he's going to talk to us about how his team views the opportunity of some of these devices and some of the investments that they're making.
Yeah, I have a short amount of time, but I just want to make it clear that how we feel about what Microsoft's doing here with the desktop. I'm trying to think of a fun way to say it. I just consider Photoshop like the apex predator on the island of Wimp for 20 years. There's nobody stalking us. We grow bored. Now this island of Nui appears, and we want to go there. There's nothing but phone OSs to get us there, though. And we're so delighted that Microsoft provided this land bridge where we can go to this new world and explain all sorts of new interactions with our users. So we plan to take this land bridge, and Photoshop has like a turning radius and a stopping distance of a cruise ship, but we're going to make best speed we can into this new world. And we'll show you some progress we're making on some of our products currently. Now this is Photoshop as it exists today on the Surface Pro screen dump, and I was actually amazed when I saw the video for the Surface Pro when they had this guy interacting with Photoshop, because if you ever actually looked at Photoshop on it, it's like a microbial UI. This guy's first calling was probably as a neurosurgeon, not a model. So now we go to the next slide, which you're going to see is a work in progress. It's an aspiration to get this out in a time that's appropriate. And as you can see now, Photoshop looks a lot better, a lot more approachable and navigable by stylus. You can actually, it's no longer a microbial UI. It's actually usable. And that's a coming attraction.
Next one.
Next slide. And this is Lightroom. I think this is the previous version of Lightroom, Lightroom 4. As you see, similar problems. Can't really click on things. Can't even really make out things. And the next slide will show you Lightroom as it exists today in the Creative Cloud, as you can get it shrink wrapped. It has a 1.5 zoom factor. And one thing I want to say about this is to inspire you guys. The one fellow did all this work for Lightroom, a guy by the name of Ben Zibel, and he just was passionate about it and did it in spare time. But it took one fellow to transform this pretty big desktop app into this new world. And I was glad to see him excited and glad to mention his name here, but it's also to inspire you, not just him. And I think the way to look at these APIs really is they're a bridge to the new world, and we should just reach out and grab the future and pull it towards us, because really what we have now are apps that are encumbered by the design constraints of yesterday's hardware, the previous century's hardware, whether it's the minimum size of an aperture on a shadow mask, on a CRT tube, or it's 1080p. All that stuff was designed around hardware that was long gone, but we're still sort of living in its shadow. And finally, we can move beyond mechanical mouse that require this much space and you're working out of place. We actually had one of the Photoshop team members had a relative that used a mouse upside down for a solid year before they realized it was wrong. And it's just that old world, we're grown accustomed to using it. It feels right to us, but it actually isn't right at all. People, for thousands of years, people have worked with their hands in front of them. It pleases people to do work with their hands. Okay. And we want to try to accommodate those people. Anyway, next slide. So what we're going to, it makes absolute, unless we just want to become an extinct species, it makes absolute sense for us to go forward and support high DPI. Because the eye, they call it you heard the word retina display, but really it's a fovea display. The fovea craves detail, either in serifs or whatever, it's typeface or details. I think you don't hear people talk about the size of toner particulate, and I think in another 4 years you won't hear that true of pixels either. They'll erase from our vocabulary. And who in the world would want to edit content, which is mostly going to be consumed on high DPI touch devices, and edit that on a non-touch device at low DPI? We think we have to accommodate this. So anyway, we want to step up to the plate and try to do what we can to accommodate the new Microsoft APIs. We want to support the native stylus support, so the native APIs, so that out-of-box experience doesn't leave you looking for a driver from a third-party company. We want to support touch as best we can. And to pull off this whole thing, you need the complete package. You've got to have a GPU backend to actually have that fast and fluid. Anyway, I'm just here to say we support them, and we want to go in this direction as fast as we can, and we're incredibly excited about it. It was getting very boring before this happened, so we're just so delighted that x86 apps and desktop apps can journey to this new world. Thank you.
Cool, man. Thanks, Jerry. Okay, so let's switch gears and actually focus in on these three areas now. And I will start off with the kind of high DPI and dense screen area. What have we actually done in Windows 8.1 to support machines like this Ativ? And just to remind you, this guy has a 13-inch 3200 by 1800 display, and that has a DPI of 276. And this is radically higher than 96 DPI, which is pretty much what the accepted norm is. Well, the first thing that we've done is to add a new scale factor in the system. We've added 200% scaling. And what this does is it allows devices such as the Ativ and the Kira Book to come out of the box and actually look gorgeous and have an optimized desktop experience. The second thing that we've done is to establish per monitor scaling. And Antoine talked a little bit about this in the keynote. But essentially what we've done is we've enabled scenarios such as plugging in external monitors, plugging in projectors to just work. And these were historically problematic because the system has a single system DPI. And that means that if an application renders on the primary screen really nicely, as soon as you drag it onto a secondary screen, it's way too big. Or alternatively, it's way too small. And so by having per monitor scaling, the system is actually able to take care of this for applications and scale them on the fly. And this is the demo that you saw in the keynote. The thing that you didn't see in the keynote is that we have an API to enable applications to customize their rendering on a per monitor basis. And this essentially is work that applications can do if they care. So in the example of Photoshop, where you really want to address every pixel and offer a precise experience, you're going to want to consider taking advantage of this API. So I wanted to take a moment and just kind of recap on what it means to be a DPI-aware application in Windows. In simple terms, a DPI-aware application knows how to scale its UI and render crisply at different DPIs. Now, for DPI-unaware applications, the system scales them and uses bitmap scaling to do so. One of the downsides of bitmap scaling is that it can result in blurriness. So I wanted to show you an example of this and actually do a comparison. You can do this. When you guys get your Surface Pro, you can actually go and do this yourselves. So what I did was went and downloaded the latest version of Firefox, which is obviously a very, very popular web browser, a great web browser. And Firefox has recently added DPI awareness. And what that means is their text rendering is now much, much crisper than it was in previous versions. If you go and install the latest retail version, you'll notice a difference. I then went and took the latest version of Chrome, which is Google's browser. And you can see here, and it's obviously hard to sort of simulate on a big screen, but if you particularly look at that lower row of text here, it comes out very much more blurrily than it does for the native application. And again, if you want to see this for real, I actually highly encourage you to download these and take a look. You may be interested where IE fits in this spectrum. IE is actually a per monitor aware application. So again, with your Surface Pro, what you'll notice there is when you have external monitors displays attached to your Surface Pro and you drag windows across, you'll see crisp rendering on both displays. So the first thing to consider when thinking about DPI support in applications is to just be DPI aware. I think that the advantages there are self-evident, and users will really thank you. And certainly, as you get machines like Surface Pro and play with them yourself, you really appreciate apps that are unaware versus apps that are aware. The second point to think about is asset support. So assets, things like bitmaps and fonts and icons, you really need to consider supporting this range of asset sizes that I show here. So in addition to 100%, then consider a 125, 150, and 200% scale factor for assets. Now, I'm not going to go into the details here implementation-wise. Steve Wright, one of my colleagues, is actually going to do a deep dive on this after lunch, and he will, I think, cover this in more detail. And I will also mention this is entirely optional. You don't have to go and support these. You can, if you want to, just support a single asset size and then scale it. It's entirely up to you. But you will get the best experience if you supply them in these scale factors. And then the final one is, if you want that control, if you want to control how content is rendered on the different screens, consider supporting the per monitor DPI API. So I'm now going to show you how you would do that. The first thing you need to do is to declare per monitor DPI awareness in your application manifest. Now, if you've done Win32 development before, you'll know that there was an existing capability here, and we've essentially added a new value to the schema that allows you to declare your application as per monitor aware. Once you do that, you then need to actually do the work to make sure that you're rendering appropriately on whatever screen your window is being displayed on. The way that you determine how to do that is using another new API, getDPI for monitor. And here you pass in basically an H monitor, which you can pretty easily derive from an H-wind, and then determine what the DPI is you need to render at. And then the final thing you need to do is to listen for a new message that we've added. We've actually added a new window message, WM DPI changed. And this message basically tells you when you need to update your rendering. It can change for two reasons. One reason is the user has dragged the window across between monitors. The other reason is, one of the things we didn't show in the keynote is you can actually dynamically change DPI on the fly now. So in Windows 8, you used to have to log out to change the DPI of the system. We've actually changed that in Windows 8.1 such that it now is changing on the fly. As a consequence, there are some claps. Woohoo! As a consequence of that, applications that are dynamically DPI aware need to listen for this message. So I've talked for a long time. Let's actually show you some code. And we're now going to do our stunt demo where we use our amazing camera here. Let's hope it all works. So I'm going to switch over, and just hopefully you'll see my screens. So what I have here is similar to the demo in the keynote, but it's actually subtly different. I have my Kira book. You can see here, not very clearly. You can't see how crisp it is. And then you can see my external display. And what I'm going to do is just drag my per monitor aware application across, and you'll see in the top right-hand corner I have this big build logo, and you can see it says 200%. What's going on there is the application it knows that it needs to render at 200%, and it's picked the appropriate bitmap. If I drag it across and continue until it resizes, what you will now see is that this is actually DPI aware. And so what it's able to do is determine that it now needs to render at 100% because I've moved it from my Kira book screen, which is a high density 200% screen, over onto my monitor out here. Now, you probably can't see that too clearly, so I'm just going to switch over and show you that native output. So you're now looking at essentially the second output of the Kira book. And what you can see now is here this Windows 8.1 DPI mode. The system DPI is 200%, and yet the application knows that it needs to render at 100%. Now, this application is written in Direct2D. It's using one of the new Direct2D features called color font. So this whole row of icons down here, this secondary row of icons, are all rendered using color font technology. And this is a new scalable capability for generating colored glyphs in the system. I'm not going to cover it in a huge amount of detail here, but there is a talk that you can go to learn more if you're a Direct2D developer. OK, so what about WPF? Anyone WPF developer in the room here? Just one or two. So for you guys, how do you think about being DPI, per monitor DPI aware? Well, let's show you an example. I'm just going to run this application. I was looking for a sample to use, and you probably gathered I'm from the UK, and obviously one of our stereotypical interests is soccer. So I thought, OK, we've got to find an example that incorporates soccer somehow. So I got this Telerik. Telerik's a control vendor that makes nice charting controls. I took one of their samples and decided to make it DPI aware. So this is just a very simple application. It shows different football teams, and you can see the results being plotted here. Now, what I've added is this readout that, again, shows me that this is using the monitor DPI of 96. If I drag it back the other way, it will actually change on the fly. And you can see now the monitor DPI is 192. And that's the DPI of the Kira Books panel down here. So let's show you how this actually works. And what I'm going to do is put a little breakpoint in here. And I've got an event that I'm handling called DPI changed. If we put a breakpoint there and switch back and drag, and then have a look at what's happening at the call stack, you'll see that I've actually written a native helper that's taking that DPI changed window message, and it's actually mapping it onto an event. So if we scroll up and have a look at my window, you'll see, in fact, wrong file, let's come here. You'll see that actually the window that I'm using here isn't inheriting from a regular WPF window. It's inheriting from this different per monitor DPI window. This is code that we've written. We're going to provide it as a sample. And in fact, if you go to the video recording of this talk and where you'll get the slides from, you'll be able to pull it down from there. And this essentially is really not a lot of code. It's written in managed C++, and it's just essentially a set of helpers around our new DPI classes. OK, so let's just do one quick thing and show you how you would customize your rendering. I'm going to hop back to my DPI changed method, and I'm just going to now uncomment this block of code. And what I'm going to do here is I'm going to change how the graph renders on the fly. So when we actually cross the boundary and decide that we're now on a 96 DPI monitor, we're actually going to change the chart type from being a line graph to a bar graph. And this is a little bit of a gratuitous example, but it's really just there to highlight the fact that if your application cares and wants to do this kind of thing, it absolutely can. And so you can see there's the line graph, the event fires, we continue to run, and now it's a bar graph. So just a little simple example of how you can take some of the new DPI capabilities and get to it from WPF. And back to the slides. Now, as I mentioned before, I've kind of scratched the surface and really just given you a taste. If you care deeply about being DPI aware, and hopefully you get a sense for the need to do so now with this new hardware coming out, then Steve Wright, as I mentioned, after lunch is doing a deep dive. He's doing an hour-long talk where he'll kind of cover this. He'll look at the D2D source code. He'll go into some more details and also walk you through our new tutorial sample that we're posting today on MSDN. Now, I'm going to move on and talk about composition and animation next. And I mentioned earlier on that the diversity of form factors is bringing with it this burden of supporting a broad range of CPUs. And at the same time, users are expecting richer UI and fluid animations and kind of interactive gestures like panning and zooming. And this is the situation that led us to create a system compositor in Windows, which is essentially a global composition engine that's been tuned to work really well on a number of CPUs, all the way from system-on-a-chip architectures like ARM, scaling all the way up to CPUs and to multi-core CPUs and discrete GPUs. So direct composition is a member of the DirectX family, and it offers a number of interesting capabilities, and we'll look at these in a bit more detail. The first is it offers GPU-accelerated animations that have been tuned to work well on a broad range of devices. They can be coordinated, so it's easy to build the kind of staggering effects that you see in the Start menu. And they also run independently of the UI thread, and this is a key capability that I'll show an example of. They can compose different content types, so there's a whole range of different bitmap types that they can accept, and they can accept DXGI swap chains, and they can also work with layered child windows as well. Now, in addition, they have the ability to do 2D and 3D, 2D affine and 3D perspective transforms. So some of the effects that you see where tiles kind of come in with a tilt effect are all achievable with direct composition. And you can also do non-rectangular clipping and opacity. So another important feature of direct composition is interoperability. You know, if you're a big established code base on the desktop, the chances are you may want to sort of start to modernize your rendering, but you don't want to do this in a monolithic fashion. You don't want to have to kind of jump in, replace your entire rendering stack in one go. Well, one of the nice things that direct composition offers is interoperability between the different rendering libraries. Pretty much anywhere you can render content will work with direct composition, and that could be a third-party rendering framework even. So Direct2D, etc. And this is something I will actually not show a huge amount of demonstrations of here, but Silvana Moncayo, who's another of my colleagues, is doing a deep dive on direct composition, and she's actually got a pretty amazing demo that shows all of these content types with animations and with kind of swap chains, protected video, all sorts of great stuff flying around. Highly recommend checking that out. What I'm going to do is firstly show you a quick demonstration of direct composition in the system, and then I'll show you some simple code. So if we hop over to number 7, I'm going to start off by just pulling up the Start menu. And so when the Start menu kind of appears, you'll notice a number of animations. You'll see each tile has got a slightly different kind of spatial animation on it. And you'll also see a kind of a fade, a global fade of all of the tiles coming in. If I bring in the charms bar, again, you see this kind of staggering effect in the system. And as soon as I start to pan and I have the inertia animations or the kind of zooming, these are all things that are coming from direct composition, the system compositor. Now, direct composition doesn't only power the shell, the Windows shell itself, but we also have it plumbed into the browser. So I'm now going to show you an example. This is a page that you can go and hit on the IE Test Drive site. And this was the team that I worked on back in Windows 8 that implemented CSS animations and transitions in the system. Now, one of the cool things about this is we're taking web standard markup, but we're actually mapping it down very efficiently onto the system compositor. And to show you that, what I'm going to do is turn on an internal development mode that isn't publicly available that shows you the direct composition surfaces. What's super cool about this is from the browser's perspective, it doesn't have to continually re-rasterize those primitives on every frame. It can essentially rasterize them once, cache them on the GPU, and then the GPU can essentially then recompose them on every frame and apply the animation curves. And you can see some of the effects. You can sort of see, you know, obviously translations, rotations, skews. These are all being applied by the compositor. Now, I mentioned earlier on independent animation, and I want to show you an example of how direct composition does that. So again, this is an SDK sample. You can actually go search for this. If you search for independent animation, it's available. And this shows you essentially the difference between a dependent animation, as we call it, and an independent animation. What do we mean by this? Well, a dependent animation is being ticked by the UI thread. And what that means is on every VBlank, the UI thread is essentially updating the coordinates, depending on what property is being animated, is updating those properties in real time. Now, the problem with that is if the CPU gets busy, if it's going out to the network, if it's a lower powered device and it's just there's a lot going on in the system, then it can't actually service those tick requests accurately. And what starts to happen is you start to see this glitching effect. And the more severe and the more kind of bogged down the CPU gets, the more glitchy the animation gets. Now, on the bottom example, that is an independent animation. And what's happening there is this is actually being ticked by a completely different process. It's not even IE that is performing that animation. As a result, the load that I'm imposing here, and this is kind of fake load. This is kind of, we're obviously generating, I think we're calculating pi like lots of times a second or something. Completely unaffected in the independent case. So pretty powerful stuff, and you'll see another example of this in my code demo in a second. Let's hop back to the slides and tell you how you can actually use direct composition in your application. So I want to give you a whistle-stop tour, and again, if you care deeply about this topic, I highly encourage you to go to Silvana's talk this afternoon, because there's really a lot of detail I can't cover in a short period of time. But hopefully you'll get a flavor. Hopefully you'll be excited enough to want to go to her talk at least. So the first thing that you need to use direct composition in your application is a factory object. And direct composition, it's a member of the DX family, and as such, it has this sort of notion of a factory object. And this factory allows me to create the ancillary objects I need to actually build up my composition tree. It also has a secondary function, which is to serve as a transaction coordinator for direct composition's transactional animation capabilities. I'll talk to you and show those to you in a second. So the next thing you need is a composition tree, and this is basically a tree structure that allows you to build out the scene that you want to display. And so if we think of the start menu example where we have all of these tiles, we may have a different visual in our tree structure for each of those tiles. And then from a parent-child perspective, if we want to apply property changes like opacity across a set of those children, we can then use the tree structure to apply those kind of nested effects. The next thing that we need is to actually render stuff and get it on the screen. And so we need to add content to our tree. And this is where we think about, well, is it bitmap content? Is it a swap chain for video? What kind of content is it? Well, direct composition supports a whole bunch of them. And you essentially need to add them to your tree, associate them with that structure, and then they'll get displayed. We then set visual properties. This could be a position. It could be things like opacity. And this is where we'd also set up animations. And then finally, we need to call commit. As I mentioned, direct composition is transactional. And this is a pretty cool feature. This enables you to essentially time all of your updates to within a single VBlank. These updates could be content updates. So you may be doing rendering operations. They may be updates to the structure of the tree. And direct composition is smart enough. It works with DXGI, and it works at a token level to be able to essentially group these things all together and have them all be atomically applied in one go. And you'll see this in a second. So let's give you the hello world tour of direct composition. We'll switch back to our demo system again, which is number 7. And let's fire up Visual Studio. Before I run it in the debugger, I'm going to show you what the application looks like. It's intended to be a really simple example. It's not intended to be a demo. Like, as I mentioned, Silvana has a much more kind of in-depth demo. And this is really just taking a set of photos from my SkyDrive and essentially allowing me to animate them. So if I press the R key, I get a randomization. And each of my surfaces is animated. I can also do kind of an insert-style animation. And again, the point here is to show you some of the capabilities around staggering and transactional behavior, and I can sort. So how does this thing work? Well, let's have a look in the debugger. I'm actually going to gloss over the initialization of direct composition where we create factories and things, and that's something that as I mentioned, Silvana will cover. And we also kind of created a photo grid data structure to store our positions. I'm not going to show you that. What I'm going to focus on is where we actually build up the visual tree. So if I step into this build thumbnail grid method, you'll see that I essentially have a pretty simple loop here. I'm looping over every grid cell, and I'm then calling this function create item with entrance animation. And that's really where the meat of the work goes on. So let's step into that guy and look what happens. Well, the first thing that we need to do is to create a surface and a visual. The surface is the thing that we need to render into, and the visual is the representation that fits into the composition tree that I mentioned. Once I've done that, I then need to actually go and draw my image. So again, I'm going to step into that method. And this is interesting. This is a new feature in Direct Composition 2 that we're shipping in Windows 8.1. that allows us to essentially efficiently use Direct2D as a rendering layer and to actually have very efficient batching operations, which means that we can do multiple draw calls on multiple visuals, and the system will optimize this and make it much more efficient than it was before. So when I call begin draw, what I get back is a D2D device context. And I can take that device context and use it to do drawing very simply. So even though this application, I didn't mention it at the beginning, but this is essentially a very simple Win32 GDI-based application. And I'm now easily able to incorporate Direct2D rendered content in there. So I'm going to do a draw bitmap call. I've got those thumbnails from the indexer. I'm drawing them as bitmaps. I'm drawing a rectangle. And when I'm done updating this particular surface, I call endDraw. And that tells me that for that particular surface, that list of things that we want to do, that list of rendering operations is now complete. So we'll step through, we'll call endDraw, and we'll step out of this method. The next thing that we're going to do is set some properties on the visual. So we've rendered our bitmap, we've got our visual, and now we're going to set an X offset, and a Y offset. And that's how we position the photo into the grid. And so I've got essentially an array of those things that I've stored, and I just apply that as I need to. And then the final thing we're going to do is to build our entrance animation. So again, if we step into that method, here we're using the direct composition device as a factory to create the animation object. And we use a set of primitives to define what the animation looks like. So this is an opacity animation. It's basically, we're going to animate from 0 to 1, which is from transparent to opaque. And to do that, I'm going to add a set of segments. The first segment that I add to the animation is a starting value. I then need to add a linear interpolation. And this is essentially what will cause the value to change over time. So for the duration of the animation, which in this case is 0.4 of a second, we'll animate on a linear fashion from 0 to 1. Now, again, Silvana, I'm really doing her talk, selling her talk here. She goes into a lot more depth on animations, and she talks about the different kind of interpolation functions, cubics and sinusoidals and things. I'm not going to cover that detail. But rest assured that it's relatively trivial, as you can see, to build up these kind of animations. So again, we'll step out, and we'll step out again. And that's pretty much it. So we've essentially created a surface, rendered into it, configured a bunch of properties and animations. And then let's disable breakpoints and run. And what will happen is that animation will trigger. Now, I want to show you something pretty cool here. So what I'm going to do is I'm going to go to my bookmark here and just turn on a breakpoint. And let's just dock the window to the left, move the application over to the right. And what I'm going to do is just use the randomize function. So I'm going to press R. And randomize is a little bit different from the entrance animation. Randomize doesn't have to go and create surfaces and render. It's literally just setting up animations. That's all it's doing. And what I want to show you is the fact that if we put a breakpoint on commit here and run to that breakpoint, when I step over this breakpoint, I'm in the debugger. All of my threads in my application are frozen, right? So when I do that single step operation, there's no code running in my process. What you will see is those animations will continue to run. So I'm going to hit F10 on the keyboard. Even though I'm broken into the debugger, my animations run. Now, the reason for that is, as I mentioned, this is a global system compositor. It's running in a completely different process, and it's totally isolated from what the application is doing. And this is one of the things that makes DCOM able to deliver such amazing performance in the system. It's a very, very cool capability. So hopefully that's whetted your appetite. And again, Silvana is here to serve your needs with her amazing demonstration this afternoon. And we'll switch back to the slides. So the last area that I want to talk about is input and manipulation. And as I mentioned at the beginning of the talk, I'm really going to focus on the highest level of those set of investments that we have. I talked about pointer, I talked about gestures, I talked about panning and zooming. It's the panning and zooming that I want to focus on. And with this set of new devices we're seeing with touchscreens, obviously panning and zooming is something that users just expect to be there and to be kind of coming out of the box. And it's one of the hallmarks of the experience that we shipped in Windows 8. So we, for that reason, wanted to develop a component in the system to make it easy to get panning and zooming. So we built direct manipulation. And this brings the same panning and zooming experiences that you see on the start screen and in the browser to your applications and gives you some of the same performance, the stick-to-your-finger performance, as well as the personality, so the kind of the bounce effects when you kind of pan with your finger. Now, in order to achieve this, direct manipulation uses a process of delegation. So it's using a worker thread internally to process the input. And this enables the responsiveness and the throughput to really be maintained accurately. So obviously, if your application is busy, like input typically flows into the system at a lot faster than 60 frames a second. And in order for the system to keep track of that and not glitch and not kind of get the input wrong, we have to have this very high priority worker thread. And it's pretty complicated to kind of build this yourself. And so direct manipulation essentially abstracts it away. All that you have to do is to declare a configuration up front. I want panning, I want zooming, I want inertia. And you then essentially do some work that I'll show you in a second, and direct manipulation takes over with its delegate thread. And then the final thing for smooth panning and zooming is you need an end-to-end an end-to-end experience. It's not just the input processing that needs to be independent, but the output. And so for that reason, we designed direct manipulation to work really well together with direct composition, so that you've got a composition path on the output side and an independent input vector on the input side, and they'll work very smoothly together. So what does that look like? Well, let's switch over to our demo machine again. And we'll now show you our new SDK sample. So this is something available. I believe they should be going live today, so you can actually go and download this. And in fact, before I show you the SDK sample, let me just show you in the system itself. So in the Start menu, I mentioned direct composition is powering the animations. Direct manipulation is powering the manipulations. And so when I do this kind of panning effect, you'll see the bounce as I reach the end. Similarly, when I do zooming, again, it sticks to my finger from a performance perspective. And there are also capabilities like snap points, so that as the inertia runs, as I kind of do a flick, we can make sure that one of the kind of pillars in the Start menu is what the animation ends up on. And that's one of the features that's built into direct manipulation. So let's look in the SDK sample and show you some of this in more detail. Here I've got two viewports. So I've got my kind of outer viewport, which has the checkerboard pattern. And you can see my touch interactions are causing this to pan smoothly. And one of the other nice features is, as I start to pan vertically, you can now see it's locking it in the vertical axis. So even though my finger is weaving side to side, I'm getting a nice constrained pan. If I come inside this nested element here, you can see that it's independently panning as well, but also you can see that it's interacting with the parent. And so seamlessly, there's handoff going between these two viewports such that interesting things can happen. One of those is something that we call chaining. So even though I'm panning on the inner region here, the inner viewport, you'll notice that when we get to the end of the content, we have this overbounce on the parent, and that's something that we call chaining. The second interesting thing is if I have a single finger down on the inner viewport and I put a second finger down, we have now something that we call parent promotion. And this is essentially saying we need to seamlessly move that stream of input from impacting the child to impacting the parent. So how do we get these things, these behaviors in our application? Well, let's hop back to the slides and give you another quick walkthrough. There are really two phases of using direct manipulation in an application. The first one is initialization, and this is where we kind of configure what we want to happen up front. And then the second phase is when we actually need to go and do a hit test and start a zooming or panning manipulation going. So the primary object we need to create to get to direct manipulation bootstrapped is a direct manipulation manager. And again, much like direct composition, this is a factory object that allows us to create ancillary objects. It also manages the lifetime of the worker thread. So I mentioned that we have high frequency input to deal with. That's all abstracted by the direct manipulation manager. The next thing we need is the viewport object. And so in the example I showed you, we had two viewports. We had the kind of checkered background and the bullseye. And so we need to create viewports that represent where our panable regions are in the application. And the final thing we need is content. Content is essentially providing a set of bounds. So For the bullseye, I think that was around about 300 pixel high object. It wasn't completely shown. That content region is defining that. For the background, I think that was more like a 2,000 pixel region. So again, content is defining how that works. Now, at runtime, what do we need to do? Well, hit testing. And what we wanted to do with direct manipulation, just in the same way as direct composition, is to make this incrementally adoptable. So if you've got existing hit testing logic in your application, we wanted to have you be able to completely reuse that and make it work seamlessly. So you get to do the hit test. You get to determine, did the contact happen on the scrolling region? If yes, then you can tell direct manipulation, go ahead and do the scrolling. The way you do that is by calling a method called setContact on the viewport. Okay, so what does that look like? Well, let's again come back to number 7 and just step through this in the code very quickly. And then we'll show you some touchpad action. So I'm going to come here and enable my breakpoints, run my application. Now again, this is, we call it a Petzl-styled application of traditional Win32. I'm initializing COM, and I'm then basically going into my message loop. And the first thing I need to do is to initialize my direct manipulation manager, a very simple co-create call here. And then if I step forward, I'm creating 2 viewports, one for the outer region, one for the inner region. Pretty straightforward. And here's my declarative configuration. So this is where I specify my translation, my inertia, my railing behaviors. And again, I declare this up front. It's a simple structure. I pass it into the configuration, and at that point, direct manipulation knows exactly what it needs to do. Now, at this point, I'm getting a WM size message coming in. If I have a look at my call stack, and that's because the window's been created, and it now actually has a physical size. And what I'm doing in response to that is to configure my region. So the outer viewport was essentially the size of the window. And for that reason, now that the window exists, we know what its size is, and we can set the rect to be that size. And we can also configure our content rects in here. So now we're all configured. What happens at runtime when I do a touchdown? Well, what happens is WM pointer down message comes in, and I need to now do a hit test. And again, this hit test logic isn't particularly complicated in the sample. It's very straightforward, in fact. And essentially, it's determining, did the contact come down in the nested viewport or in the parent viewport? In this case, no, I touched outside. It didn't. If I touch inside the bullseye, my hit test logic will return true. So again, this is the hit test logic that exists in your application. It's not something that we're doing, but it's the means by which we trigger the manipulation. And that's pretty much it for this demo. I will direct you to Nick Wagoner's talk. He's doing a much more in-depth talk on input, and he goes into pen and inking. He also looks at interaction context. So again, if this is a topic of interest, highly recommend checking his talk out after lunch. I want to move on and just talk to you about precision trackpads very quickly. So if we switch back to 1, let's do that. I mentioned before at the beginning of the talk, I'm sure there's a lot of people with frustrated experiences with working on touchpads. Well, much in the same way as we made a massive improvement to touch in Windows 8, so we're improving the touchpad experience on Windows in Windows Blue. And we've been working with a set of partners. So I've got a machine up here that I'm about to show you that we worked with Intel on. And this, we also had some other co-engineering partners, Synaptics and Elan. And they've actually taken a precision touchpad device and retrofit it into this device here. So a precision touchpad is our new initiative to improve touchpads. And the things that we wanted to really address were, first of all, consistency and reliability. So many times when you reinstall the system, you can't find your touchpad drivers. Like, where are they? I can't find the right version. Very frustrating. And the second thing is consistency. If you were to go into, for example, a Best Buy and kind of go try a bunch of different touchpads, you'd probably come away with very different experiences, very different materials. You know, some of them are rough, some of them smooth, some of them respond well, others don't. Very inconsistent. So we wanted to fix that. We also wanted to bring the fluid interactions that we have for touch and the integration with direct manipulation to the touchpad so that you can actually do sort of two-finger scrolling and get some really highly performant manipulations. And we also, another big area is, you know, how many of you have had this problem? You're typing away and you kind of accidentally put your thumb down, your palm down, and you're getting these clicks, and those clicks are annoying because they change the focus, and suddenly your text isn't going into the right window. Really frustrating. I know my father, whenever he gets a new laptop, how do I disable this trackpad? And it's me that has to help him. We want to make that thing of the past, so we've invested in accidental activation prevention to help really filter out these kind of non-deliberate touches on the touchpad and make it a much better experience. So with that, let's switch over, and we'll go back to our stunt camera again and show you this Harris Beach system. And again, this is a co-engineering effort with Intel, and it's actually a development system that I'm showing here. So this is not a shipping device. These devices will be coming to market in some limited availability this holiday, and then shipping in volume over the course of the next year. So what we'll do to show off touch is I'm going to come to Wikipedia. This is a pretty big Wikipedia page, and you'll see the regular kind of touch panning experience that you'd expect in Windows and touch zooming experience. If I come down onto the trackpad, I get exactly that same experience. And the reason for that is we've done the work to hook up to direct manipulation, so it's incredibly responsive. And I definitely, for those interested, come up and actually try it, and you'll feel an amazingly responsive behavior. If I do 2 fingers, and hopefully you can see this on the camera, you'll see again, zooming is exactly the same way. Very fluid, very stick to the finger there. We've also done a couple of other things. We've done gesture support. So if I swipe in from the edges of the trackpad, I initiate the edgy behavior from the right, and from the left, I get the application switcher. So we haven't just kind of had this really beautifully smooth and high-performant experience from a panning and zooming perspective, but also done gestures. And finally, accidental activation. So what I'm going to do here is I'm bringing out WordPad. I'm going to type with one hand. And as I type, I'm just going to kind of deliberately tap the touchpad. I don't know if you can see me doing this. It's hard with that camera angle. There you go. And so what you'll see is all of those taps that I'm making on the touchpad as I type are being filtered out. We do kind of contact geometry analysis and some very intelligent algorithms in Windows itself to really kind of make this a great experience. Now, what does this mean to a developer? Well, great news. If we come back to this same SDK sample I just showed you, I'm going to again switch over to show you the output directly. I'm going to run exactly the same code you saw. And what you'll see now is that to get the panning and zooming experience to work with the Precision touchpad, it's basically one line of code. And it's essentially just handling a new message called DM pointer hit test. And this message is sent to the application when I do the sort of 2-finger down initiation of the scroll, or of the pan, I should say. So if I put 2 fingers down and start to pan, you'll see that this message gets fired. It's my exact same hit testing logic. I determine where did that go. Was that in the inner viewport, the outer viewport? And away we go. We get all of our built-in kind of ballistics, our nice bounce effect. We get all of our parenting and chaining. It's all exactly the same. Now, this is basically free in modern apps. So if we come into the News app, for both HTML and XAML, Precision touchpad integration is essentially plumbed into the system. So I get this beautifully responsive behavior. It's plumbed into the browser and available for users. So that's Precision touchpad. Who liked it? Anyone? Who wants a Precision touchpad here? Me, I want one. Very awesome. Okay, let's switch back to the slides. There are a couple of other aspects of input, and I don't have time to go into this. We actually pretty much out of time here. So just to very quickly go through these, if you want to go beyond panning and zooming, we do have support for gestures. And this is where interaction context comes in. And Nick Wagoner, as I mentioned, will be covering that in much more detail this afternoon. And we have support for inking. I mentioned real-time stylus and recognition. So if you have specific needs to do inking, not only for input, but also thinking of Photoshop, if you want to use it as a creative input modality, we have those APIs available. And finally, if you want to go down to the metal, we have the WM Pointer family of APIs. And this is not just as simple as a window message. We have a whole series of APIs for getting contact geometry and pen pressure and the tilt of the pen even. Very powerful stuff. So for folks that are interested, Nick Wagoner's talk is this afternoon. It's at 3:30. Highly worth going to. He's got a very elaborate combination of all of these inputs in a single application that I think you'll find pretty interesting. So I'm pretty much at the end of the content that I have. I want to just remind you that there's this amazing diversity of PC form factors, and they're coming to market now. We saw them in the keynote. I've given you some examples up here on stage. And in Windows 8.1, the platform gives you a whole set of tools that you can use to take and leverage in your desktop application to really go and take advantage of those form factors. So the first one we talked about was DPI and dense screens. This is really something you need to think about. Remember this device here that we showed you. These devices are really coming in volume this year. And so if you have a desktop application, you really need to think about supporting high DPI. Secondly, fluid animations and the challenge of bringing these fluid experiences not only to high-end CPUs, but also to kind of resource-constrained devices. We've done that for you. Direct composition is optimized to work really well across the range of devices. And then finally, input. I only gave you a flavor here. I showed you panning and zooming specifically, but we have a whole rich input stack unified across mouse, touch, and pen that you can take advantage of to really take and work with these new devices. So a couple of resources to share. These are the various talks that I've been alluding to. The first one is on high DPI. That's right after lunch in this room. Then we have the mouse, touch, and pen talk that's after that. And finally, Silvana's talk later on this afternoon about composition. There's a couple of other ones I'll call out. Firstly, if you're building modern apps and you're interested in supporting these kind of dense screens, then Sarah McDevitt has a talk tomorrow that covers scaling in modern apps. And then finally, I talked about color fonts briefly at the beginning of the talk. If that's an area you're interested in, and D2D in particular, then Dan McLaughlin has a great talk today at 2 o'clock. The code that I showed you, some of it was SDK samples you can go download. Other aspects were demos that will be, I mentioned, they'll be available on the site where the slides and the video is there. So the WPF example, you'll be able to go download that and play with it. And we also have a white paper on DPI. So again, we've tried to make this easy. We've got a walkthrough, so you can literally go and take a look at that, study it if you want to support DPI. And with that, I will say thank you very much. I hope you have a fantastic lunch. 14 seconds left. And really wish you the best of Build and have a fantastic day.